Monday, Tuesday, and Wednesday of this week will just be regular days as far as we're concerned. I will be here. Now, starting on Thursday, I won't be here. I won't be here Thursday, Friday, next Monday, or next Tuesday. But hopefully things will just continue to move along as if I were here. Meaning, on Thursday in class, if you're in class, the sub will pass out your study guide. I will tell the sub that you're allowed to access YouTube on your devices, and I will do the study guide on YouTube for you so you can, I don't know what I'm trying to say. I'll do the study guide for you, so the notes for the study guide will be on YouTube. Got it? Then on Friday, you'll take the quiz in class. It'll be a multiple choice quiz, and at the end of class, I want you to move your answers over to focus under alerts. Quiz, it'll be quiz 7. Then on Monday, in class, you'll just come into class, you'll take your phones out or your tablets or whatever you have, and you can access YouTube, and you're going to get the notes and the practice problems. Okay? And then you'll do the same thing on Tuesday. And then when I get back on Wednesday, we'll just resume how we normally do things. Does everybody understand that? Great. You guys at home understand that?
Mm-hmm.
Is that a yes?
Yes. Yeah.
Okay.
I do at least.
There won't be any Zoom meetings Thursday, Friday, Monday, or Tuesday. There will be no Zoom meetings Thursday, Friday, Monday, or Tuesday. All of your information will be on YouTube. Anything that you need to complete will be on focus under alerts. And as always, your study guide and your quiz will be on the resource tab. It'll be a PDF file for you to open and complete. And then Friday's quiz, you'll transfer your answers over to focus. So everybody clear on what's going on the next, I don't know, 7 or 8 days? Very good. Very good. Okay. All right, today we're going to be talking about solving systems. Using matrices. Solving systems using matrices. All right, you can use a matrix to represent and solve a system. You can use a matrix to represent and solve a system of equations without writing the variables. A matrix is a rectangular array of numbers. You usually display the array within brackets. The dimensions of the matrix are the numbers of rows and columns. All right, so here's 3 columns. Your columns are your vertical sets of numbers, and this matrix has 2 rows. That's your horizontal display of numbers. So here's your 3 columns, and then your 2 rows. Each number in a matrix is a matrix element. You can identify a matrix element by its row and column numbers. in matrix A, A12 is the element in row 1 and column 2. A12 is the element 4. All right, A12, that's row 1, column 2. All right, so row 1 horizontally, from left to right, top to bottom. Row 1 is up top here. Column 2 is right in the middle here. So there's your A12. The order of the element that they're describing is row by column. All right, row and then column. Row and then column. So let's put another matrix here on your paper. We'll call this matrix A as well. And then horizontally, we're going to go 4, -9, 17, and 1. Zero, 5, 6, 9. -3, -2, 10, 0. And if we're asked, what is if we say, or if you're asked for A23, so A23, that's row 2, column 3. So A23 is 6. If you're asked for A12, A12 would be row 1, column 2. So row 1, column 2 is right here. So your A12 would be -9. And element A 34 or 34. Let's use another color here. So we go row 3, column 4. So row 3, down 1, 2, 3, column 4, 0. Everybody good with that? All right, you can represent a system. You can represent a system of equations with a matrix. Each row represents an equation. So if we had a system of equations, and our system of equations was x plus 3y equals 7. And 3x plus y equals -8. And we wanted to represent that in a matrix. All right, so here's what your system of equations would look like. And here's what it would look like as a matrix. E1, 3. We draw a line to represent the equal signs, a vertical line, and then your 7. So what you can see here is all we're doing is we're listing the coefficient in front of the x, in front of the y, and then the constraint. All right, so the second row, what would the second row of this matrix look like here? What goes here? Good, a 3, and then a 1, and then a -8. All right, so there's your system of equations. There's your system of equations represented as a matrix, okay? And you can see how this works alphabetically in your columns. It goes x, y, equal sign, and your constraint. So always want to make sure that your coefficients are listed alphabetically in the matrix. So here's another system. If our system is 2x plus y equals 9, x minus 6y equals -1, then our matrix that represents that system would be 2, 1, 9 in your first row. And what goes in your second row? Good, a 1, and then a -6, and then a -1. Now let's do one more of these where some of the variables are not necessarily in the same exact order, just so that we understand what manipulations need to be made when you're converting a system of equations to a matrix. So let's say we get this system. And the system is x minus 3y plus z equal to 6, x plus 3z equal to 12, and then a y equals negative 5x plus 1. Now, before we transfer this to a matrix, do you see how this first equation is in the order of x, y, z, equal sign, and a constraint? It's in the order that we've been dealing with. But in this second equation, there's no coefficient in front of the y. When there's no coefficient in front of the y, it means that there's a 0 in front of the y. Okay? So this first equation can stay the same. It's x minus 3y plus z equals 6. This second equation needs to get adjusted a little bit so you don't make a mistake when you're converting. So the coefficient in front of we got x here. Now, there's no y value. So we're going to say plus 0y. And then we're going to go plus 3z. And it's still equal to 12. And this third equation, it's not in the same order as the first or the second equation. So we have to put it in the same order as the first equation. We need our x value, we need our y, we need our z, we need our equal sign, and we need our constraint. So in this case, you would have to add 5x to each side. And you would get 5x plus y equals 1. All right, so now when we rewrite this thing over here, we go 5x, we got a plus y, we've got a plus 0z, and that's equal to 1. So now your system is set up to rewrite it as a matrix. So here would be the matrix that represents that original system. All right, we got a 1, negative 3, 1, vertical, 6, bracket. Our second equation, 1, 0, 3, and 12. And then our third equation, 5, 1, 0, and a positive 1. All right, so that's taking a system and writing it as a matrix. Any questions on that? All right, so now we're going to take a matrix and write it as a system. All right, so now we're going to get the matrix. And if you're given this 2x3, or I'm sorry, this 2x3 matrix, we got 5, 2, vertical 7. 0, 1, and a 9. All right, so you can use A, B, and C. You can use X, Y, and Z. You can use M, N, and O. We're going to use X and Y here because I think that's what everybody's the most used to using. So here's our system of equations. This first row would be 5x plus 2y is equal to 7. And now this 0 that occupies, this is row 2, column 1. This element 0 would be a 0x, agreed? But you don't write 0x, do you, when you're writing it in the form of a system? Okay? You don't write the 0x because 0 times x is just equal to 0, and you don't write the 0 either. So this 1 would represent a 1y, so we just go with a y equals 9 right here. All right, so that's writing a matrix as a system. One more of those. Let's go another matrix. Let's say the matrix is a 2, 0, vertical 6, 5, negative 2, 1. That matrix written as a system that's 2x is equal to 6. And the second row is 5x minus 2y is equal to 1. Any questions on any of that? Pretty simple, pretty kind of straightforward. It's more terminology than anything. Just remember when you're referring to elements in a matrix, it's row first, column second. And make sure you remember that your columns are always vertical. Rows are always horizontal. I've got a handout for you for the next 3 days. So your practice problems for today it's going to be on page 179. Problems 3 through 23. Page 179, 3 through 23. You guys that are e-learning, as soon as I pass these papers out in class, I will upload these same pages under the resources tab on our webpage. So just be patient. Give me 5 minutes or so to get that uploaded, and then you'll have 3 pages worth of practice problems, and you'll be working on page 179 today. So try to make sure that you also check focus for homework after you get this assignment completed. So you Zoom guys are welcome to exit the meeting. Like I said, check under the resources tab in about 5 minutes, and I'll have these pages posted. Otherwise, see you again tomorrow. Talk to you again tomorrow. Whatever we're calling it. Zoom you tomorrow. Yeah, just fill out your planner.